G'day, rates. Let's meander through the questions from our second revision sheet. The first is it asks us to identify some different types of graphs. So we have a frequency histogram here. The second, we've got a pie chart. I think most people are all over pie charts. The third, we've got a bar chart and a stem and leaf plot. Okay, so we're asked now to calculate the mean, median and mode. So that's question 3. This next one is an interesting one. So we want to see if we can, let's pop a little table in here. And the first thing we've got to do is the name of the data. Then we're going to have our tally, and that's going to give us the frequency. So let's call the name like the score, right? So the data goes from 4 and 6 all the way up to 18 seems to be the most. So let's say if we do it this way, 0 to 4, 5 to 9, 10 to 14, 15 to 19. So now we start putting the tallies in. Let's see how often something here occurs. We've got a 4, another 4, another 4, a 2, a 4, and a 4. So when you add that up, 1, 2, 3, 4, 5, 6, the frequency is 6. So now I'm going to go through the data and look for the numbers that are between 5 and 9. So the second one is a 6, so that's 1. Then we've got another 5, an 8, another 6, another 6, an 8 and a 6, another 6, a 7, an 8, and a 9. So now we count the number here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think it's about 12. If you get a slightly different count, that'll just be my bad counting. That will keep going quickly. So the 10 and the 14, so we've got a 10, 12, 14, so that's 3, up to there, 13, 14, and 12. So if we add those up, 1, 2, 3, 4, 5, 6. If you're doing them by yourself, you can put the fifth one as being the little cross mark. That'll make them a lot easier to count. And those that are 14 to 19, so there's one there, one in there. 18 is in that range. We've got a 16. I think it's just the 3. Look, I might have made a mistake, but that gives you an idea of a frequency table. Now we come to these calculations of mean, median, and mode. So mean, when we're calculating mean, it is the sum of the data divided by the number of data. Okay, so I've got my calculator here. Let's just add those up. 2 plus 5 plus 1 plus 3 plus 4 plus 5 plus 3 plus 2 plus 3 plus 1 plus 3 plus 0 plus 6 plus 5 plus 3 plus 4 plus 3 plus 6 plus 5 plus 0 plus 1 plus 2 plus 7 plus 8 plus 1 plus 3. So I got that there. When I add the data up, I get an 86. Look, if you get a slightly different number, just mention to me, but it's just a matter of adding all those data up. And I'm just concerned that I might have misadded doing it quickly. So and how many have we got? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So there's 27 different data points. So when we divide 86 by 27, we get 3.2 if we round it to a decimal place. You can put 3.19 if you want as well. The mode is the most common number. Now, I often think the easiest way to do the median first because you put them in order, but let's see which one seems to occur the most. I thought it might have been a lot of 2s. So let's see how many 2s. 1, 2, 3 2s as we go across. So 3 2s is 1, 2, 3, 4, 5, 6, 7 3s. So I'm thinking that may well be the most. So we got 1s, 0s aren't that common. 3 4s aren't that common. So yes, it's going to have to be, the most common is going to be the number 3. Now the median's a little bit tricky. I wish I didn't have quite as much data here. The first thing you're going to do when you calculate the median is to write them in order. So let's go 0, 0, 0. Now we're going through, get the ones. There's 1, 2, 3, 4 ones. 1, 2, 3, 4. So look at the 2s. 1, 2, 3 2s. 2, 2, 2. We said there were 7 3s, so I'll trust myself there. 3, 3, 3, 3, 3, 3. How many 4s? We've got 1. We've got the 1 4, 2 4s, 4 4. We've got 1 5 here, 2 5s, 3 5s, 4 5s, 5, 5, 5, 5. And now we get to the 6s. 1, 2, 2 6s, 6, 6. There's at least a 7 and an 8 in there, so there's 1 7 in there and 1 8. 7 and an 8. And so what I do is I start counting from the outside in. Or you can actually go along and say, okay, there's 1. Yeah, if we count from the outside in, we say, okay, that one there. Maybe we can do it this way. So let's quickly grab this. So the 8 outside in. Second one in, 0 and the 7. The 6 here, the 0 here, the 1 here, 6 here, the 5 here, another one here, another one here, another one here. So we're just counting our way in. 5, 1, 2, 2, 2, 2. And look, I'm a little bit worried because there's so many numbers that I might have got this wrong, but it's actually going to definitely end up that our middle numbers are 3. If you end up with 2 middle numbers, which you can if you've got an even number of data, we shouldn't. We should just end it up with 3. But if you've got an even number, you add the 2 numbers up, divide by 2. In this case, the middle value is going to be 3. The range is the highest minus the lowest, which is going to equal, in this case, the biggest number is 8 minus 0, which equals 8. Okay, so there are our answers there. Now we're referring to this diagram here. How many cars are in the car park all together? So the way we're going to do is add them all together. So let's work around from other. So 11 there plus 21 plus 21 plus 15 plus 12 plus 5 plus 34 plus 18 plus 3. That equals 119. So that's the number of cars in the car park. What was the least common colour? Interestingly, we can't quite tell this. The least common colour was orange, but there were 11 others. So it suggests to me that there are probably 11 cars. It might be like some that have 2 colours, and some that might just have really rare colours. But from the data we've got, there are 3 orange, which is the smallest that we can identify. But we might add there are 11 others that might have fewer numbers of a colour. How many cars were blue? So just reading off there. So straight off here, we've got the 12 were blue. Okay, now we're getting a bit of probability. What's the probability of a green car? So probability of green. So our probability rule equals, it's the event. So it's the number of times we get a green car divided by the total that we've got. So we've got 15 green, and we added up before that the total was 119. Okay, and you can express it either way. You can express it as a fraction. 15 on 119 would be absolutely fine. I'm just having fun with the fact that OneNote calculates it for me, so you can also express it as a decimal, 0.1261, which we'd probably round to 0.13. We'd say go to 2 decimal places, round the 2 up because there's a 6 following. Next question, what's the probability of a white car being in the supermarket when you choose, right? So there's 34 whites. Probability of the white equals 34 divided by 119. That's an absolutely fine answer. There's no way of simplifying it, but there's also a decimal there. Okay. What's the probability of a red, yellow, or orange? A little bit trickier here. We have to red. So probably a red, orange, or yellow equals. So if we go back here, there's 21 red, 3 orange, that's 24, and 5 yellow is 29 of those colours divided by 119. That would be a fine answer. But we can also put a decimal, 0.24. Question 5. Okay. Table below shows the numbers of dogs. So the table over here shows the number of dogs owned by people attending a dog show. How many people attended the dog show? Okay. It's a little bit tricky here, I think. Right, so the number of dogs won, so 20 people had one dog, 24 people had 2 dogs, 15 people had 3 dogs. There's some keen people with their dogs. 10 people had 4 and 6 had 5. So we can add those up. 20 and 24 is 44, and 15 makes 59, and 10 is 69, and 6 is 75. So 75 people. 75 people attended the dog show in total. And you can use a calculator for that. What's the probability they own 2 dogs? So let's remind ourselves of our rule. Probability of 2 dogs equals the number of times the event occurs divided by the total. So the number of times you have is 24, and we said the total number of dogs was 75. 24 divided by 75, and I don't think there's any way of simplifying that fraction. So 24 divided by 75 would be it. Next one's a little bit tricky. Probability of more than 3. Well, the same rule, it's the event. The number of people who own dogs have more than 3 dogs divided by the total. So more than 3 means they're going to own 4 or 5. So there's 10 people that own 4 and 6 that own 5. So it's going to be 16 divided by 75, which is an absolutely fine answer. I don't think there's any common factors that we can make that fraction simpler. Let's move on to the next question. Okay. We're looking at marbles in a bag. So it asks us to list a sample space. Sample space is just a fancy word for all the different options. So the different options are we could get red, 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 green, 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 or blue, 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 blue. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's the marbles in the bag. And we're going to need to know this. So I might just put in brackets that there are 15 marbles. Okay. Next one is the probability of red. Remember, the probability is the event that you're looking at divided by the total, or like divided by the sample space if we're using that language. So the event here, the number of ways of getting a red, there are 4 red divided by the 15 in total. Okay, let's move on to the next one. The probability of green. The event divided by the total. Okay, the green is 1, 2, 3. 3 divided now 15. You will get quite a good answer for doing that. But you can simplify this. You can divide both the top and the bottom in this fraction by 3. It's going to give you 1 divided by 5. That is the best answer. And the last one, the probability of blue, event divided by the total, which is 8 divided by 15. I don't think there's any way of simplifying that. 8 divided by 15 because there's 8 blue marbles and the total marbles 15. We'll stop there. So we've got up to question 6.